In this lesson, we'll talk about learning target number 4. By the end, you should be able to predict the products and write the balanced chemical equation, including states, for double displacement reactions. Remember that double displacement reactions involve two ionic compounds that exchange cations to form two new compounds, like switching dance partners. To help with the order, I always remember the first goes with the last, so A goes with Z, and the third goes with the second, B goes with X, to get the product elements in the correct order. In a double displacement reaction, you must have proof that new products are formed to claim that a reaction actually happened. If all the products are AQ, there is no reaction. Just a mixture of ions is formed. The following can be used to prove that a double displacement reaction happened. The first being a precipitate formed. A precipitate is a solid compound made after mixing two aqueous solutions. Mixing hydrochloric acid and silver nitrate is an example. The hydrogen goes with the nitrate and makes nitric acid. The silver goes with the chlorine, and because silver chloride is an insoluble compound, a solid will be made during the course of this reaction. This solid is visible to the naked eye, proving that the elements have changed partners. The second piece of evidence is if a gas gets produced. Some ionic compounds, when formed, immediately do a decomposition reaction, forming gas and water. Here are the 3 examples that we want you to be able to recognize and memorize. Whenever performing a double displacement reaction, and you form H2CO3 as a product, really, this does not exist for very long. It changes into water and CO2 gas. The CO2 gas forms bubbles, which are visible to the naked eye, proving that the elements in the double displacement reaction rearrange their partnerships. Another example is ammonium hydroxide, NH4OH. When you piece this together as a product, really you should be writing water plus NH3. NH3 gas, sometimes you see bubbles, but it has a distinctive odor. It smells like cat pee or hair dye. The last example you need to memorize is H2SO3. It immediately decomposes when it's formed into water and SO2 gas, which you'll see bubbles again. Here's an example. Sodium carbonate mixed with hydrochloric acid. Sodium carbonate is most commonly known as baking soda. The sodium will go with the chlorine and make NaCl, and the H will go with the carbonate and make H2CO3. Really, what's happening is this H2CO3 will decompose into water and CO2 gas. Because we see the bubbles, we know that the hydrogen has migrated from a partnership with the chlorine to a carbonate. The last piece of evidence you can have is a neutralization reaction. If you recognize that the reactants are an acid and a base, then you know that the double displacement reaction will actually occur. Physically, we can track this by using pH meters or pH paper. When we mix the reactants together slowly, the pH will change, going towards being neutral. Remember, you can recognize acids because they start with H's in their formulas, and bases because they have hydroxides. Whenever you write a double displacement neutralization, try to avoid having this as your second product. Whenever you have hydroxides and hydrogens going together, write it as water. H2O. If you have any extra atoms, still write it as water, not H3O, for example. The extra atoms will take care of themselves when you balance the chemical equation. Let's try some examples. Write balanced chemical equations for these types of reactions and identify whether they are a DDP, a double displacement precipitate, a DDG, a double displacement producing a gas, or a DDN, a double displacement neutralization reaction. Or, if you don't have any proof, write it as a no reaction. Pause the video here until you have your answers. Here are the answers to the try-some questions. When hydrochloric acid is reacted with calcium hydroxide, I'm going to have a double displacement neutralization reaction. I know this is a neutralization because my first chemical starts with an H and my second chemical has hydroxides. My hydrogen is going to go with the hydroxides and make some water, and the calcium is going to go with the chlorine. Make sure you re-crisscross this formula. To balance the equation, I need to put a 2 in front of my HCl and a 2 in front of the water, and include the states. Because calcium chloride is an ionic compound in a double displacement reaction and it's a product, I need to check on the solubility table. It's a soluble compound, so it will have an aqueous state. When calcium chloride and sodium phosphate are mixed together, you're going to make calcium phosphate and sodium chloride. Now I need to balance my equation. And include states. Calcium phosphate is a solid, whereas sodium chloride is aqueous. Because I have a solid product, this is a double displacement precipitation reaction. When ammonium sulfate and lithium hydroxide are reacted together, ammonium hydroxide and lithium sulfide are made. Now both of these have an aqueous state. You might be tempted to call this a no reaction, but you have a gas-forming molecule here. NH4OH, as soon as it's made, decomposes into water and NH3. This makes this a double displacement gas reaction. And finally, when zinc nitrate and barium chloride react together, you would make barium nitrate, which is aqueous, and zinc chloride, which is also aqueous. You also don't have a special gas-forming molecule made. Therefore, this is a no reaction. Try out the practice questions listed in the textbook.